Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst is an end-to-end data lakehouse platform built on Trino, the query engine Apache Iceberg was designed for. Starburst has complete support for all table formats, including Apache Iceberg, Hive, and Delta Lake. And Starburst is trusted by teams of all sizes, including Comcast and DoorDash. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst today and get $500 in credits to try Starburst Galaxy, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm interviewing Kevin Liu about his use of Trino and Iceberg for Stripe's data lakehouse. So, Kevin, can you start by introducing yourself?
Of course. Hey, everyone. My name is Kevin Liu. I'm currently a software engineer at Stripe. In the past 3 years, I've been working in the big data infrastructure ecosystem, working primarily with Trino and Iceberg. Recently, I've taken on a new challenge working in data sharing, which is really awesome. I'm here to talk about use cases for Trino and Iceberg.
And do you remember how you first got started working in data?
I just stumbled upon it, honestly. I think I started a new job at Stripe and put into a team working with Trino and Iceberg and had no idea what it was. And then it was just, a bunch of learning, a bunch of contribution to open source, working with the community, and getting to know the technology.
And in that context of Trino and Iceberg, the ways that it's being applied at Stripe, I'm wondering if you can just start by giving a bit of an overview about how it's being used, its overall position and responsibilities within the broader data architecture of Stripe, and some of the initial experiences that you had getting onboarded into that ecosystem.
Yeah. So a lot of the context before my time, I've only read and have, historical context on, but I can give you an overview of what it looks like today. So Trino and Iceberg is what we use majority for business analytics, data analytics, dashboarding, anything to do with reading your big data set. So a lot of transformation, a lot of dashboarding presentation is done on the Trino layer. And that's there's a clear distinction between our use for Trino and our use for, let's say, something like Spark, right? Like Spark is used for transformation, it's used for writing and transforming big data sets versus our current use case right now for Trino, which is like reading. So that's the big distinction. And historically, we actually move away from Redshift into Trino, and we've kind of reached a scale and the need to outscale Redshift, and Trino, the distributed nature of it, and the fact that you can scale up and scale out Trino clusters and have it work on your big data set really helped us kind of scale our organization, scale our need for business intelligence and data analytics. So that's kind of the context behind it. And currently you can everyone who is using any kind of data and doing any kind of analytics at Stripe uses Trino to power that in the back end.
Given the very read heavy nature, and I know that there's been a lot of work in recent years put into being able to optimize for things like query caching, read speeds, etc. I know that Iceberg helps in that, but I'm curious, what are some of the edge cases that you've run into and that you've seen other people run into in that very analytics heavy, read heavy environment of being able to query across these large data sets? And maybe if you're able to give some sense of what large means in your context and just some of the ways that you've started to hit against some of those limitations in your experience.
Yeah, I think going on the kind of how big the data is, right? And what is the bottleneck that we were facing at Stripe? I think one, the entire Stripe ecosystem of data is massive, like petabytes of data or more, and kind of doing the analytics for that, joining data, making sure that we can do reporting, we can do operational analytics. A lot of that is powered by Trino, and it's powered by, many, many clusters running many, many machines. And I think one of the bottlenecks we face was actually the concurrency nature of like running queries, right? It is really popular for people at Stripe to just pop into like an internal website, write some SQL query against our big data store, and find some kind of data and results from that. And it's to the point where it's like almost a central repository where, if you want data to be easily accessible, you dump it into this ecosystem. So then everyone else can just go to a centralized website and query for that data. So yeah, I touched up on like kind of the concurrency nature of it, which is from what I've read, the kind of bottleneck for Redshift is when you have thousands of people all trying to query at once, that's something that Redshift wasn't good at the time. And because we can scale out Trino, have multiple clusters, have multiple machines backing that compute, and Trino is made for this kind of like very fast ad hoc analytics that really helped kind of magically make everyone's query run effectively and run in a fast amount of time so that people are okay with like working in this realm. And then another bottleneck we faced was kind of the whole like Hive versus Iceberg, right? Like as with any organizations who started like 5, 8, 10 years ago, Hive was kind of the main aspect of data platform, and especially in big data, right? Like everyone writes on Hive. Spark writes to Hive. Trino used to have Hive connector as like the initial like component of like the Trino connector, but then eventually everyone moved from Hive to Iceberg, and there's a clear reason for that. I think one of those, and people repeat this over and over again, is how like Hive handles partitioning, and the fact that you have to like list in a blob store like S3. And it's just like created in a different paradigm for before, right? Like Hive was made for Hadoop, which has a more efficient list operation, and Hive for S3 and blob store, now listing becomes very expensive. And a very real concern when you're working with big data is like partitioning and having to list all of the partitions. And when you do more partitioning, like multiple levels of partitioning, let's say I want to partition by like a timestamp plus like I don't know some kind of like clustering ID, it just like blows up the kind of complexity of like how much listing you have to do. So first of all, listing in S3 is really expensive. Listing S3 files really add up in terms of cost. Secondly, it's just not efficient. Like listing, if you have like 1,000 files and you have to list them every time, it becomes really tedious and like it's memory intense. Plus, it's very slow. And when you're using the Hive ecosystem, a lot of the time you have the Hive Metastore as the kind of metadata layer. And Hive Metastore, when you're listing thousands of files, really can just like blow up on you, which is not fun as a big data engineer. But yeah, I think a lot of the reasons we ended up with Trino and Iceberg has to do with all of these like underlying bottlenecks, and it really helped us to use these technologies to like solve for those bottlenecks.
Digging a bit more into the specifics of your infrastructure, it sounds like you are using S3 or some analogous blob store as the storage layer. Obviously, you're using Iceberg as the table format. I'm wondering if you are using the Hive connector for Iceberg as the means of storing the pointers to the appropriate metadata, or have you moved into the REST catalog functionality that Iceberg has been adding in recently, and some of the ways that you think about that decision?
Yeah, I think a very general overview is, I already alluded Spark for writing and transformation, Trino for reading the data, and then on the kind of data file side and the kind of table format side, we currently use, we use Blobstore S3 for storing the actual data. But on the table format side, we're actually kind of stuck in between this like Hive and Iceberg. land where we use both, and we're still like slowly migrating from Hive to Iceberg. So, which means for both Spark and Trino, we have to use both Hive and Iceberg because some tables are in Hive format, some tables are in Iceberg format, and there's a slow transition to move everything into Iceberg. And both Hive and Iceberg require a kind of a metadata catalog. And we started with Hive Metastore. That's like the thing that Hive requires you to have to run this. And actually, Iceberg, the initial version of Iceberg, can run off Hive Metastore because when it was first implemented, it was like a direct replacement for Hive, right? So we're still stuck in the like we're using Hive Metastore, but there's a slow migration to like how do we get out of the Hive Metastore? How do we get out of the Hive table format? And as you alluded to, I think the answer is the REST catalog. And I actually wrote some Substack articles on this, basically saying that hey, even if you currently have the Hive Metastore, you can add a REST catalog component on top of that so that it's a level of indirection between your compute and your catalog. And as of now, Trino, Spark, and a lot of other engines all support this REST catalog. So from a big data engineer perspective, the REST catalog really helps to decouple the engine and the underlying table format. And it allows us to do the migration kind of transparently without our users kind of knowing what's going on in the background. So it gives us the tool to in order for us to like create all of these like migrations and improvements and optimizations.
And I was just noticing recently too that you actually are at least involved in, or if not completely authored, the Python Iceberg REST catalog. I'm wondering what were some of your inspiration or motivation to put in that work and some of the ways that you're hoping to see that used.
Yeah, I think I'm really excited for the Reds catalog, honestly, because just from an industry standpoint, everyone has standardized on this format. So, you can go to Spark, you can go to Snowflake, you can go to like any engines or vendors, and they have a plugin for the Reds catalog, right? Which means there's a standard now where you can say, I have this concept for a REST catalog, and I can take that and go wherever, right? And this really helps with the like avoiding vendor lock-in, making it so that it's like very easy to transition from one platform to another, and it really like levels the playing field for like what the vendor should provide, right? Like if it's so easy for me to take my data and go somewhere else, my current vendor better give me the best available technology, like optimization, everything. Because where else, if someone else is better, I could just go there. But yeah, and then coming back to the Python Iceberg REST catalog implementation, that's been on my mind for quite a while, just because, for the majority of my time at Stripe, I've been dealing with the Hive Metastore, making sure it doesn't blow up, looking at like, what it's doing in the ecosystem. And I really think this like REST catalog idea is a direct replacement, if not more, for the Hive Metastore. And there's like a lot of interesting things you can do once everyone's on this kind of technology slash implementation.
Moving back into some of the work that you're doing at Stripe, the ways that you are taking advantage of the Trino and Iceberg combination, I'm wondering what are some of the projects that you have been most excited about or most interested by in your work at Stripe, and some of the specifics of Iceberg, Trino, the combination thereof that have led you to being able to employ them beyond just the very simple, I have my data somewhere, I can query it.
Right. Yeah, I think the biggest thing that I'm like really proud of is utilizing these two technologies and kind of how do you say it, like syncing them in a way where it's not just Trino queries Iceberg and get the result. Like Trino itself is a really powerful engine. It allows you to read from whatever data source that you can connect to, right? You can say, I have a Postgres database, and I can connect that to Trino, and magically now you can write some SQL against a Postgres database somewhere else, right? So the idea that we're working with at Stripe, the thing that I'm really proud of is kind of using this ecosystem and plugging in things all the way back to Trino. So I'll give you a concrete example, right? Like I talked about the Hive meta store. I talked about like Iceberg. Iceberg itself has a lot of metadata. Because it's a table format, it can store more than just the underlying data, right? It can give you the details on like partition scheme, on the schema, on metadata information about how big your table is, like what is the distribution of your table, what is the min max, like all the stats. And all of this metadata in Iceberg land is in like metadata files, right? And as a big data engineer trying to figure out what's going on for a specific Iceberg table and digging into it, it was really difficult to like look at a specific Iceberg table and do some diagnostic on like what's going on in that table, right? So one of the things that I created at Stripe was to plug in that metadata ecosystem back into Trino, so then I can now write SQL against that and like diagnose my Iceberg table using Trino. So there's like two aspects of this. One is Trino has this idea of like metadata table where, instead of reading the data itself, you can read the metadata of the table format. So like things like partitioning, I could just do select all from the table, like $ partition. And now instead of reading the data, it gives me partition data back. And it's in a tabular format. So now I can join it if I want. I can like aggregate it, perform any kind of analytics I want. So that's one piece of it where you can plug the metadata back into Trino itself. The second piece is on this like catalog slash like Hive Metastore piece, right? Like Hive Metastore is essentially a catalog of all of the data and table that's registered as Stripe. That's that you're able to read as Stripe. And the idea is like, how do we analyze data so then there's an easier way to like figure out what's going on in our ecosystem, right? So, for example, like the Hive Metastore itself is backed by an underlying database. For us, we use Postgres, right? I want to read that Postgres data and let's say figure out how many tables are there in total at Stripe, right? How many Hive tables, how many Iceberg tables. So what we did was we plugged the underlying database itself back into Trino. So then now I can query that database to say, hey, like, what is this table? What is the last time it was updated? Like these metadata are all located in the database. And by plugging it in directly to Trino, I can query it in real time because underneath it's issuing a table directly to that database. Mind, you should create a read-only database if you're doing that for your backing store. And the third piece is we took these two ideas and we looked at this and we say, okay, this is great. Like we have a pretty nice like infrastructure component to plug back into Trino. What can we do about that? And we're running this like infrastructure essentially to provide the query, like SQL query capability at Stripe. And a big thing we're facing at the time is kind of analytics on what is being run on Trino, like how much CPU it's using, how much memory it's using, are we blowing up a cluster, like are we optimizing the cluster? So the idea is to like log each query that's run on Trino. And Trino has a nice connector that gives us that information along with like a lot of information on like how much memory, how much CPU, like a bunch of usage information from Trino itself. So what we did is we took that information in the connector, we dumped that into another database, like a Postgres database. So every time a query is run, we would like upsert a row that says, here's the information about that query into our Postgres database. And then we plug that back into Trino. So then now on Trino, you can say, okay, in the last 5 minutes, how many queries were run, right? And what like this is something that we're interested in specifically is was there a spike in how many queries were submitted in the last 5 minutes? And now you have like almost real time, near real time analytics on like everything that's run on your platform. And that's really helpful for us from like the infrastructure standpoint, because now it gives us more observability and it gives us just a component in our platform that we can add more information to. Like, for example, we open up Trino to like services within Stripe as well, right? So now we can say, okay, well, how many, like, what is the resource usage of this specific service, and what kind of query is it running? And it's just like a nice piece of component that we can now like add more and more metadata in and use that for like analytics.
And with that meta capability, the metacognition, if you will, about your data platform, being able to round trip all of this information through that system, I'm wondering what are the types of use cases that that supports and some of the types of questions that people are asking and answering about the data platform itself using those capabilities.
Yeah, I think a big one, and we always get asked this, is a data producer now has a V2 version or an upgraded version of the table, right? And the main question is, hey, I want to deprecate this, but I don't want to break everything. So, can I go and figure out who's using this table, either tell them to, hey, there's a new one, or just figure out like, when I do deprecate this, it's not going to break any like obscure work stream, right? So for us, being able to, analyze every query that was run on the platform and being able to analyze like exactly what tables were used, and that's a capability that Trino has for to give us like in this query which tables were used, which tables were queried, and that like once we expose that information, like that use case is like super easy to achieve, right? Like for me, I could just go like select all from this like query database where the affected table is like this thing, and then what I talked about before with like the metadata on top, like included in this query, we can actually point back to where this query was originated, right? It could be like this service is actually running this query, which has this table, or these people are querying it, or it's like this dashboard that we're using, or like you querying this table. So then now you have a pointer back to the original use case, and now you can say, okay, well, let me email everyone to say, hey, like we're deprecating this. So that's like a very common use case that we have is to say like table deprecation, table translation, and there are a few more that's more like on the infra side, like for example like rate limiting and like making sure that people are using their fair share of like CPU and memory consumption, making sure that like people's queries are optimized, that you know please include a partition filter on your thing so you don't read like 10 years of data. They're like things like that we can use historical like query information on in order to like help us make decisions for like current use cases.
Because of the fact that you have Trino as the read path, you have Spark as the write path, I'm sure that there are other systems that may be able to hook into those Iceberg tables. What are some of the ways that you are accounting for the fact that maybe not absolutely every read path or not absolutely every point of access to a particular data location does go through Trino, in the course of being able to determine, can I safely deprecate this table? Can I delete it? Can I stop feeding data into it? Just some of the ways that you are managing the multi-tool nature of the ecosystem, both at Stripe and just in data more generally.
Yeah, I think everything becomes hard once you start adding new tools, right? So, Flink is a very real use case for like streaming and real-time analytics. Adding Flink to the mix adds a extra level of complexity in this ecosystem. So, back to your question about, Spark on the right path, Trina on the repath. Like, how do you know that you're covering all the bases for like the usage for like, let's say, one particular table, right? And this is where kind of I'm really excited about the REST catalog and this like iceberg notion of like having a catalog is because you can really push down everything I just described. And I say push down because I imagine like Trino on top and like, the table formats below it. You can really push down all of those features on a catalog level, right? So things like logging usage, right? The catalog technically knows exactly when a table is used, right? Because you're using the catalog for that, right? Like for Trino to say, I want to read a table, it has to go to the catalog, grab that information before coming back to say, hey, this is where the table is. And so we're really seeing this like catalog as the centralized place when you have multiple engines, right? You can implement an engine specific feature when you don't have many engines. I can implement everything I said once in Trino and another in Spark. But when you have Flink or another engine, you got to redo everything else again, right? So the idea is if we can push all of these features lower in the stack, then the whole ecosystem is kind of engine agnostic. So then we can plug in another engine and still get the same kind of feature set without any changes to our ecosystem. We're not there yet, but that's kind of the idea. And you see like catalog vendors kind of have similar idea. Like Tabular was really into this like idea of security on the catalog layer. So you don't have to re-implement security in every single engine and have customized code for every single engine because it's a lot of effort engineering wise and there's nuances to that. But if you can lock it down in a catalog layer, then you can bring that catalog to wherever engine and get the same behaviors.
In that future state of the catalog knows all of this information about the ways that the data is being accessed, and also to the work that you were doing with your REST catalog implementation, I imagine that a lot of that information can be captured based on the interaction with the interface by which the catalog is queried or interacted with. And I think that by moving more into that REST API and away from the Hive Metastore space, that it makes it a little bit easier to implement that as maybe not necessarily across the board every implementation is going to do it, but it makes it easier to put that logic into the REST API layer so that you can have some of the information about what are the access patterns, how often is it happening, what are the sources by which these accesses are coming from.
Yeah, I think a lot of the feature sets and the ideas for this like catalog layer comes from Hive Metastore. Like Hive Metastore contains a lot of feature sets, and this is like good and bad, right? Like there's like a multitude of feature sets that were implemented on Hive Metastore because it was like the centralized place that everyone runs, and it's like the meeting spot that everyone comes to, right? And it itself has some like bottlenecks in terms of like performance, but the idea still holds true, right? Like we were, with the Hive Metastore, we were doing our customized code for, like security, for authorization, for like, data, what's the word? Like we have like this idea of like data regionality, like data has to be in specific region. And we're enforcing that in the Hive Metastore layer. But it's the same idea, right? Like now you just replace Hive Metastore with like the REST catalog. I mean, you have to be within the Iceberg ecosystem, but the REST catalog is like in similar vein, performing the same duty where it's the centralized place that every engine has to come to in order to do some kind of work. And like in the Delta table world, like Unity catalog is doing the exact same thing, right? Like Unity catalog is this piece of code that you have to like reach out to when you try to do some kind of write in the Delta world. right? So I see it as like, res catalog is the basis. It's just, a spec with an implementation, but with that, you can add a bunch of feature sets to like improve upon this idea.
So we've talked a lot about the ways that Trino and Iceberg are useful, both in isolation and in combination. What are some of the aspects of those technologies that are still a pain point, and some of the ways that you hope to see them evolve to improve the overall experience of working with them? Some of the features that maybe you think should be pushed into one or the other, and maybe some of the features that could be pushed into one of those layers but definitely shouldn't, because then you end up with some bloated monstrosity that does too many things.
Right. I think first of all, like managing Trino is really hard, especially for a big organization with growing needs and growing, bottlenecks for like this and that. And just managing the infrastructure itself becomes tedious, almost like a operational job. So that's one thing, right? Because we run open source Trino ourselves. So a lot of the operational burden is on the team, right? And because of how widely used it is and how critical it is to like daily operation of the company, it becomes critical for us to run this very well with like minimal downtime, with very strict SLAs. So that's the hard part. And maybe we'll explore like using like a vendor solution, or something that will alleviate the maintenance burden from us, right? And there's like, Starburst is one of them, Athena. There's like other players in this where we can say, okay, well, you know we can handle the kind of tooling and the ecosystem around, but running the underlying infrastructure. And for us, it's just like a black box, right? We just run some compute nodes and we send SQL in, and results come out. So like if we can delegate that somewhere else, I think it will alleviate a lot of the maintenance burden for us. And I think the other thing on Iceberg is that I think managing Iceberg is still difficult, because this idea of like, you have to register the table in a catalog. There's like metadata involved, and it's not as straightforward as just some files in a folder, right? As Hive, right? So there's like a level of abstraction in the metadata, and when that breaks, it's a little bit harder to fix. And this is where like software engineering and tooling comes in, is to say, okay, well, if we want to restore a table to what it was before, we have to manage all this metadata, but we can use software to help us do that. And just thinking back, like another thing that I think has been improved since I've worked on Trino like last year, is this like control plane for Trino. I know in the community there's a lot of movement for I forgot what it's called, but it's essentially a control plane where you're able to manage multiple Trino clusters simultaneously, and it handles routing for you, and it handles like resource usage and everything. And it's a, a part of the open source Trino community that I think it's really helpful for like any company that's managing more than one cluster. So I'm like really happy about that, and seeing that like the open source community and the open source contribution is still very active in that realm. I think we should explore something like that, and use something like that in the future.
In your experience of working with these technologies, dealing with the scale complexity of Stripe, what are some of the most interesting or innovative or unexpected ways that you have seen Iceberg and or Trino used either in isolation or in combination?
Yeah, I think one of the most surprising thing, and this is like both good and bad, is that because we run Trino, and Trino has a very simple SQL interface, and we end up exposing an API layer where you can say, post some SQL, and get a result back. Because of that and the simplicity of like just integrating with that and have like once you integrate with that, you're able to access the rest of the data ecosystem. We've seen a lot of use cases where, instead of properly integrating with the underlying data, people start to say, hey, like, why not just submit some SQL onto this endpoint? And voila, you're in this ecosystem right away. And there's like good and bad in that, right? Like some of the things we've seen is like, integrating operational data to say when something happens, right to the database, and on the other side, like constantly pull from this endpoint to do some kind of aggregation to say, okay, if it's above this threshold, like Slack me or like page me or something. So it almost goes into the realm of like observability and also like what Datadog is doing, right? Like observability and like alerting and like all of that. And it's like a surprising use case, but I can see why it's like that. But like we're trying to figure out like, is this the best use for that kind of data? And if it's not, is there another way we can expose the same set of functionality in our platform? Maybe using another technology or maybe using like some other tooling to support that. But once you open up a SQL endpoint to the whole world within Stripe, it's very very fun to see what engineers come up with to like make it go into that like data ecosystem.
Going back to the performance piece, I'm wondering what are some of the transition points as far as use case where latency becomes problematic and people try to pull data into other systems either for caching or they ask for a different storage engine or a different storage system for being able to reduce some of those latencies, and how much latency people are willing to deal with even when maybe they shouldn't.
Right. Yeah. So that question on latency is a very interesting one for us running the infra to answer, because sometimes you run a SQL query, and because it's like ad hoc analytics, right? Let's like focus on that use case. You expect it to come back relatively fast, right? Like I don't want to run a query, go get a coffee, come back, and it like just finish. So people have this expectation of like it should be fast, right? But when you peel back the layers and you look at what some of the queries is doing, it's like querying like petabytes of data and doing some kind of filtering on that. And if you look at it from that perspective, like wow, I like that query finished within 20 seconds. That's amazing, right? Like how did they ever do that? And this is where like Iceberg comes in to help out, right? Like Iceberg provide us the tooling to do some kind of optimization, either through like partitioning or like sorting or like just like metadata pruning. So it helps, but at the end of the day, you still have to pay that compute cost in order to like get the data that you need. So a lot of like the ideas from our end is to say, well, can we actually tell our users that, hey, you're querying a lot of data and you're doing a lot of compute, and you shouldn't expect it to be like finished within 5 seconds, 10 seconds. So a lot of this question is like, you know, people come to us and say, hey, like, is like the staying slow today, right? Like, is our infrastructure very slow today because I'm doing this and it used to run like in 10 seconds, now I'm waiting in 30 seconds, right? And there's a multitude of reasons why that's happening. Like maybe the query is being queued because the cluster is busy. Maybe like the underlying data grew, right? Like maybe it was like not that much before and now it grew 10 times. So then if you're doing joins and blah blah, it just like explodes, right? So we helped a little bit by providing a like some kind of progress bar to say, here's how much work you're like. There's a difference between waiting for like a circle to like just continuously run versus like some kind of progress bar that like actually shows you the progress, right? So that was like our initial answer to say like, hey, it's doing work in the background, it's just not done yet. And that helps a little bit. And then the second one is like showing that, hey, like this is how much work you're doing, right? Like this is how much compute you're doing. Like in CPU hours, it took like um, 20 like different machines this amount of time to finish your query. So like it kind of resets the user expectation of saying, hey, why is it so slow to, oh my God, like it's doing that much work and it finished that fast. Like that's so cool.
And in your work of building these systems using Trino and Iceberg, digging into the technologies and the community, what are some of the most interesting or unexpected or challenging lessons that you've learned?
I think the most interesting, and this is one I'm like really thankful for, is like the open source community around both Trino and Iceberg and how supportive people are, both from like the committer and the people working on the project and the general community surrounding it. Like, contributing, asking questions, collaboration with both of the community has been like really helpful and like really easy to work with. And, I've, you know, through my work, I've helped like contribute some of the pieces that we work on and, help like kind of evangelize some of the things that we can do with it. Like, for example, the things we talked about with like reading like query metadata, all this kind of metadata. I gave a talk on like Trino Fest on a couple years ago, and a bunch of people reached out to me. It's like, hey, how did you do that? How can we do that? And just like meeting other folks from other companies like, Lyft, Pinterest, Quora, like people who are running Trino and Iceberg at scale and kind of taking learnings from them, kind of sharing notes on like, what problems you're facing, what problem we're facing, how are you solving that, how are we solving that, has been really great. Shout out to some of the folks in the community like Manfred, who I met recently in Seattle, who signed a Chino definitive guide for me, which is awesome. And Brian Olson, who wrote this initial blog post on like Trino on Ice, which I took a lot of inspiration from and kind of welcomed me into this world of like using both of the technologies. But I think, just to summarize, it's like been really fun collaborating with both like the contributors and the people who work amongst like different companies.
And for people who are working in the space of dealing with data, particularly if they already are relying on S3, but maybe if they're just considering whether to go that direction, what are the cases where you see Trino and or Iceberg as the wrong choice or Lakehouse as an architectural component as maybe the wrong choice for a given use case?
Yeah, I think the way I see Lakehouse and this whole architecture, and specifically with like something like implementation wise as like Trino and Iceberg, is like this ecosystem and these technologies are kind of a re-implementation of like what a database is, right? Like if you look at Postgres and you take that apart and you say, what are all the components? Then you can map that kind of like one to one with like the current ecosystem, right? And it just breaks apart that like database idea. But if a database is all you need, right? If you can run your entire stack on a Postgres, on a Aurora, on whatever, and you don't have any bottlenecks with that, great. Like that's all you should do. If you run into like issues of like, running analytics slows down your operations or your like inserts, and you're sharing the same database for both analytics and operational, maybe then you can start looking into this realm of like lakehouse. And especially if you're already on blob store, the like it's just so easy to read from blob store using Trino and Iceberg, that like it's honestly the best way to like analyze data in that realm. And specifically, if you're within S3 and you're using Hive, go look at your S3 bill for like lists and how much money it's costing you to do list, and give Iceberg a try and see like how much of that bill you save just from like that one operation alone. So it's like moving to like more and more feature sets within this ecosystem, right? Because if you're facing problems with like file caching, right? Like a feature that Trino has is like using Alluxio for like caching. If you're facing issues with, let's say, like using a table format, it's like you have a bunch of Parquet and you want to analyze it and you want to like put it in like a table format, you can use Trino to like put it in Iceberg, put it in Hootie, put it in Delta. Like Trino is supportive of all three formats. You're able to read whatever data you want and then write to those formats. So there's like a lot of different use cases and a lot of different like tools involved, but these technology gives you the tool in order to like help out, like figure out exactly what you need, exactly what your bottleneck is, and to solve for those.
As you continue to rely on and invest in the Trino and Iceberg infrastructure at Stripe, what are some of the capabilities or integrations or projects that you're excited to dig into?
Yeah, I think for me personally, I think one is using Trino on the right path. I think there's explorations there. And we've seen companies like Lyft, like Pinterest already use that for some of their use cases. And especially with this thing called Project Tardigrade, where Trino is now resilient to partial query failures. So before Tardigrade, queries, when something happens, the entire query fails, and you just have to rerun the query again. And that's by design because Trino was designed to be very fast and in memory. With Project Tardigrade, there is checkpointing so that you're, even if something fails, your query will continue running, and it almost look like a Spark engine, right? Where you say, well, I'll just do some query and just wait for an answer or result to be back to come back to me. And because of that, I think there's some use cases that we can explore for like writing, and like instead of there's certain use cases that are probably better for Trino to write than Spark to write. So that's one of them. And I think another one that I'm interested in exploring is more on like the table format, the like data lake side of things for like data sharing, to say like, how do we efficiently share some data across platform, across engine, across cloud, so that, I can take one piece of data and make it available everywhere. And that's more of like the Iceberg side and the REST catalog side. But, Trino as an engine that supports, every single cloud storage and supports every single table format can be helpful in this equation because it's just a really powerful tool for like whatever you want to do in like data land.
Are there any aspect of Trino, Iceberg, and your experience of working with them that we didn't discuss yet that you'd like to cover before we close out the show?
I think that everyone should be on REST catalog, and that there's almost, I would say, almost no reason for you not to be, but that's kind of a bold statement. But I think there are a lot of interesting feature sets that once you're on the REST catalog, you can start adding more and more features, and it just gives you the platform engineer the flexibility to add more and more features. And the REST catalog is compatible with whatever catalog you currently have. If you have Glue, if you have Hive, if you have uh, JDBC, Postgres, whatever, you're able to connect the REST catalog to that, and then use the REST catalog as an interface and plug that into Spark, plug that into Trino, plug that into like Athena, Starburst, like whatever engine vendor that you have all supports this, right? So now this is like the centralized piece for everything. And once you're on this, you're able to move wherever you want, and you just have the flexibility from a platform level. But yeah, I think there's still a lot of active development in this area in the open source as well. So if anyone's interested, contact me, contact the open source community. I think there's like a lot of innovations in this space.
Absolutely. Well, for anybody who wants to get in touch with you, follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think my perspective has always been re-implementing what we had in the database world into this new like cloud slash disaggregated like separation of compute and storage architecture where you have specialized technology for everything that was previously in the database world, right? So like the res catalog as a data catalog, compute is everywhere, right? Like you can bring, if you're able to bring your data to whatever compute, you can use whatever compute, right? And then you can optimize your data, your file format into like table formats. With Iceberg, you can do like indexes and like a lot of these like interesting features are implemented on top of like table formats, like indexes, security, like encryption. So like once you're in this realm, the possibilities are endless, and there's a lot of innovations right now in this world. So it gets me really excited, I think, and to work in this. And on the Trino side, they're always like implementing new things, coming up with new features. The engine just gets much better like throughout the years. So I think wherever like technology we use, Trino itself as a place that you can plug into other ecosystems will always be useful as a tool at the end of the day.
All right. Well, thank you very much for taking the time today to join me and share your experiences working with Trino and Iceberg and some of the interesting applications and combinations that you've been able to do with that. It's definitely great to hear from people who are digging deep into these systems and understanding some of the new and interesting ways that they can be applied. I appreciate your investment into making the REST catalog the preferred means of interacting with Iceberg. I agree with you on that. So thank you again for taking the time, and I hope you enjoy the rest of your day.
Of course. Thanks for having me.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.